All right, guys, so we are doing equations now. So we're going to use those rules that we did last section to kind of help us, solve the equations, right? Obviously, your goal is to figure out what the variable is equal to. So you're going to try and, condense things down to make it, less terms, and you're going to try and hopefully get some things to eliminate. Okay. So these are what I have there at the top. They're pretty easy. We should already kind of know them, but they should help us, eliminate some things. Right. So obviously, common logs, right? Your base every time is what? Is 10, right? So log of 1 is going to be what? 0. Right? Log of 10 would be 1. Log of 10 to the x is x, right? So if the base and the exponential share the same base, right, everything cancels out and you're just left with what the variable is, right? Same thing for if you're taking the log of one particular base and you raise it to that same base, what are you left with? X, right? Good. All right, so it works the same thing for natural logs. So ln of 1 would be 0. ln of e is 1. ln of e to the x would be x, right? So if you have an exponential function, e to the x, right, and you want to get rid of that base there of e, right, you'd have to take the natural log on both sides. Same thing if you raise ln using e now as your base, it would also give you x. Okay. All right, now this is for really any generic base, right? Still be 0. If the two numbers are the same, it's 1. It's going to cancel it out, give you x and x. Okay? So obviously stuff that we've seen. That work? Okay. All right. So the first thing we're going to work on is just exponential equations. All right. So what you guys, your goal should be is the first thing you should always try and do is get both sides to have the same base. Okay. So that we can set up that, if the bases are the same, then the exponents are the same. So that should always be your first line of attack. So if the bases are the same, then the exponents are the same. All right, so that should always kind of be your go-to kind of rule when you're doing these. Now it's not always going to work. Okay, so if it doesn't work, then you're going to have to use some properties of logs to help you get the variable to come down. Okay, so for the first one, you have 2 to the 3x is equal to 16 to the 1 minus x. All right, so the first thing I want to try and do is, again, get the bases to be the same. All right, so is there a way that I can get the same base on both sides? Tyler? Right. You have 2 to the 3x. 16 would be 2 to the 4th. Right, so on the right side, what does that turn into? 4 minus 4x, good. Okay. All right, now that you've set the bases are the same, it's very easy. You just have to now set your exponents equal to one another. 3x equals 4 minus 4x. So that gives me what? 7x equals 4. X equals 4 over 7. So when we're doing exponential equations, do you have to pay attention to the domain? Typically what is the domain for a exponential function? All real numbers, right? So really whatever number that you get, it should work out. When we move on to log equations, that's when we're going to have to pay attention to what we get. But for right now, exponential functions, you can kind of go from there. Okay. So what about the next one? What would be your first kind of rule here? Yeah. Right. Good. Divide the 100 over. So that would give me 1/5 to the x over 4 is equal to what? Cam? Good. Okay. All right, so now that we've gotten rid of the 100, right, we have an exponential on both sides. Can I get the bases to be the same? Yeah. Good. So 1 over 25 is the same thing as 1 over 5 squared. So now that I have the same base, I can just set up my exponents to be the same. So then x would be positive 8. Good. Is there another way you could have done that? Yeah. So change both bases to be 5 to the negative 1. Yeah, right. Yeah, that could have worked as well. So if you use base of 5 on both sides, you still get positive 8 as your answer. Good. Okay. What about that one? Yeah. Okay. So that would give me 2 equals 3 to the negative 0.1 t. Okay. So I have a base of 2 on the left side and a base of 3 on the right side. So obviously they don't really have anything in common, right? So getting the bases the same side really is not going to benefit. But ultimately our goal is to figure out what exactly t is equal to, right? So I need to figure out a way so that I can bring that variable out of the exponent, okay? So there was a thing that we did last section when if you have something as an exponent and you want to bring it down, what would you have to do? Right. Right. So what we can do is we can take the natural log on both sides. Now, you could do, say, log base 10. That would also work. But when you are solving equations, ln is more common. Right? You'll see that in more books and things online and things like that. So the natural log is just more common. So we'll take the ln of 3 to the negative 0.1 to the t. Okay? All right, so now that I'm taking the ln of this exponential, right, what can I do with this exponent here? Yeah. Move it to the front, right? Right. So this whole thing here can be put now out front. So you have ln of 2 is equal to negative 0.1 t times ln of 3. All right, so now you've got it down, right? Now you need to isolate the variable, right? So what can you do next? Yeah. Divide it, right? Yeah. So you got ln of 2 divided by ln of 3 is equal to negative 0.1 t. Okay. And then the last thing would be to what? Now, if you are dividing by negative 0.1, what are you really multiplying by? Yeah. Not negative 1 over 10, but negative 10, right? So if you're dividing something by 0.1, you're really multiplying it by positive 10. But since we have the negative, it would be negative 10. So you have negative 10 ln of 2 over ln of 3. You guys are more than welcome to leave it like that. Now, if you want to just type it into your calculator, you can get the decimal answer. But that is perfectly acceptable. Is everybody okay with that? Good so far? Okay. So where's my variable now? In the denominator, right? I need to figure out a way, how can I get it out of the denominator, right? So what can you do on both sides so that the denominator is eliminated? Yeah. Good. Multiply both sides by that denominator. 1 plus 3e. Okay. So that gives me 75 times 1 plus 3e to the negative 2t is equal to 100. Okay. What's next? Cam? Okay. That's going to give me 1 plus 3e to the negative 2t equals 4/3. You want to subtract the 1, right? So 3e to the negative 2t equals 1/3. And then what? Don't want to do that yet. Divide by 3. So that would be e to the negative 2t equals 1/9. Now I can take the natural log on both sides. So if I take the natural log on both sides, right, what does the left side turn into? Okay. Negative 2t. Good. Right? And the ln and the e will cancel each other out. Right, and then you're left with ln of 1 over 9. And then the last part would be to what? Good. Okay, so what we have right there is perfectly acceptable. How else can I change that? So, yeah. Ln of 9 negative first power. Okay, so you're doing ln of like that. Okay. So what can you do with that? Negative ln of 9, right? Bring down the negative 1 over negative 2. Okay. Can you do anything else more with that? So the negatives will cancel out, right? How else can you write 9? 3 squared, right? So now you have ln of 3 squared over 2 right? You can bring down the 2 there. So the 2's cancel out, and you're just left with ln of 3. All right, so any one of these answers is perfectly fine. All right? Now, the reason that I show you this is because maybe, like, on a test, on a multiple choice question, this might not be one of the answer choices. Okay? So even though you did all the work out, you might have to go a little bit further, maybe move some things around, right? And I might give you, any one of these possible ones as answer choices. Yeah. Yep, that's another way you can do it too. Yep. Yep. Good. Okay. Letter E. You have a fraction again, right? So how can you get rid of it? Yeah. Right? So that's going to give me e to the x is equal to 5e to the x minus 5. Right? So if you multiply the denominators over and then distribute the 5, that's what you get on the right. Okay. So what can you do next? What do you have? Do you have any common terms? Yeah. Good. Yep. So both of these are common terms, right? Here you have 1e to the x. Here you have 5e to the x. So you can put, they're just like variables. You can put them together, right? So you have negative 4e to the x is equal to negative 5. Divide by the negative 4, right? So now that you have e to the x equals 5 over 4, how can you get the variable? Yeah. Right. Yeah, you're not going to multiply by ln, but you're going to take the ln. Yeah, so it's a function rule. So that will cancel that. ln of 5 over 4. Good. Okay. All right, so I see that I have an x on both sides. I have an e to the x on both sides. So what this maybe looks similar to is if you had, say, 3 to the x equals x squared, right? How would you solve that from, algebra 1? Yeah. Not even that. Even easier than that. Not even that. I can move the x squared. I would move the 3x over so that you can set it equal to 0. Right? And then once you have that set up, right, you have everything on one side, what would you do from there? Factor, right? Okay, and then you go from there, right? So it's going to work the exact same way for this type of problem. We're going to put everything on one side here. Right? So I'm going to have 0 equals x squared e to the x minus 3x e to the x. All right? So what would you, yeah? Then, so what you'd be left with what? 3 equals x? Right, but what other solution are you missing now? Right. So you came up with that solution, which is good, but you're still missing that one. Not a different solution, but you're for this one you'd get 2 solutions, right? You'd have 2 answers. So how you did it though, you would only get the one answer, right? So usually you want to, if you see like an x squared and then a variable on the other side, you want to try and get all of your variables to be on the one side so that you can factor. So that just makes sure that you're coming up with all the solutions and you're not missing any. What else? Yep, good. What else? Yep. So I can take on an x and an e to the x, and then what would that leave me with? Okay. X minus 3, good. Okay. So right now you have 3 kind of scenarios you need to set up. What would those scenarios be? Okay. Very good. Right. All you have 3 factors here, right? You have x times e to the x times x minus 3, right? So this is your first factor, your second factor, and your third factor, right? I forgot the 0. Sorry. Okay. So obviously, x equals 0. You're done with that one. So that would be one answer. And then this one obviously would be x equals 3, right? Now for this one though, e to the x equals 0. Is that possible? No, right? No matter what I plug in for x, it's never going to come out to be 0. All right, so that's like extraneous solution. Or no, actually. All right, so this scenario here is just not possible. So the only 2 answers that you are left with would be 0 and positive 3. Yeah. Mhm. Yeah, I guess you could do that. Because then you'd still get the same 2 answers, right? Yeah, I guess you could do that. I would recommend kind of putting everything on one side, just so that you're not missing anything. But that's certainly a possibility. Okay. So 2 more. All right. So this second term should be e to the x, not e to the negative x. That's the typo. All right. So you have 3e to the negative x minus e to the x equals negative 2. What I'm going to do is I'm going to rewrite the first term. Make it 3 over e to the x minus e to the x equals negative 2. Okay? I want to get rid of that fraction. So what's going to help me eliminate that? Okay? Right, good. Multiply everything by e to the x. Okay, so when you do that, right, the first term just gives you 3 because the e to the x cancels. And then when you do e to the x times e to the x, what does that give you? 2x, good. And then you're left with negative 2e to the x. Okay. So again, I would put everything on the one side. So I'm going to put everything on the right side. So that would make me 0 equals e to the 2x minus 2e to the x minus 3. All right, so when you see something like this, think of this as like a quadratic. Right? If I had, say, x squared minus 2x minus 3, and I had that set equal to 0, right? You would factor it, obviously, give you x minus 3, x plus 1, and you would go from there, right? So when you see e to the 2x, it's almost like you have your variable and it's being squared, right? So how could you break up e to the 2x? Right. So when you factor it, right, your one binomial would have e to the x, the other one would also have e to the x. Okay, so you're looking for now factors of negative 3 that add up to be negative 2, which would be that, right? Okay, so now if you multiply this through, right, e to the x times e to the x, e to the 2x, e to the x times 1 is e to the x minus 3e to the x gives you that. And then obviously that gives you that. All right, so what should you set up from there? Nor? Good. So for the first one, you have e to the x equals 3. Right, you move the 3 over, and then do what on both sides? ln, right? Good. So x equals ln of 3. And then the other one, you have e to the x equals negative 1. Is that possible? No, right? So that one you're kind of done. Right? So your only answer here would be ln of 3. I'm not going to do the last one. All right, so what I want you guys to do is, get into groups, go down to where it says practice, part 1. Those are all exponential equations, right? So all the techniques that I just showed you can be used to solve those equations there, okay? So, get into groups and see if you can come up with the answers, okay?